This video is on exercise 1 from the lesson 21 in the grade 7 module 3 book, found on page 131. So in this exercise we have Marcus. Marcus thinks that the surface area of the right triangular prism will be half of that of the right rectangular prism and wants to use the modified formula SA stands for surface area, equals 1/2, and then we have these 2LW plus 2LH plus 2WH. Do you agree or disagree with Marcus? We're going to have to use the nets of the prism to support our argument. So let's kind of look at where this formula comes from here. SA equals, I won't highlight the 1/2 right now, but this formula right here, this is something we did not explicitly go over in the last lesson, but we kind of touched on it. That formula right here comes from up here. So up here in this example 1, we learned how to find the surface area of a rectangular prism, and we can see they have the same dimensions, 3, 4, and 6. So what we did is we took the area of the top and the bottom. We see how those are the same. So it was base times height. Remember, base times height can also be called length times width. So those right there, we look and we say, oh, well, they were the same thing. 3 times 4 plus 3 times 4. So a shortcut we could have done is S equals 2 times 3 times 4. Because we had something being added to itself. So that's the same thing as multiplying by 2. And we see that with the other ones also. We see that with the area of the rear side and the front side. It was again b times h, which is also length times height. And we had the same numbers. So we could have shortened this up by putting plus 2 multiplied by 3 multiplied by 6. And same deal in the back. Same deal in the back. We see we had 4 multiplied by 6. So the left side was the same as the front side, same dimensions. So this formula here could have been shortened up. So how does this all connect? So this all connects because let's say this surface area of a rectangular prism equals, and I'm going to adjust this a little bit. I'm going to say that this 3" was the W, the width, 4" was the L for length, and then 6 was the H for height. So look what we got. In this first part, 3 was the width. So instead of 3, I'll write 2 multiplied by W. 4 was the length. 2 times WL, width and length, plus, next part, 2 times 3 and 6. Well, 3 was the width, 6 was the height. So the next part of this formula is 2 times width, W, and H, height, plus 2, 4. 4 was the length, 6 was the height. So our formula for any rectangular prism, if you want to find the total surface area, is 2 times the width times the length plus 2 times the width times the height plus 2 times the length times the height. To shorten all that up, we would just write it as 2WL plus 2WH plus 2LH. Width, length, H for height. So down to here, down to exercise 1, we have pretty much that same thing, maybe a little bit of a different order. This is what we were just talking about. But why is there a 1/2 in there? Let's start to explore that a little bit. So what they did in this one is they made a triangular prism. So a triangular prism, or I should say a right triangular prism, is a prism, which is just a 3D object with 2 triangular sides and 3 rectangular sides, and the triangular and rectangular sides meet at 90 degrees. I had to abbreviate rectangular so you could fit it on your page. So that is your official definition of a right triangular prism. Now this object right here, what they did is they took the prism, the rectangular prism from the previous example, that opening example, and they kind of cut it into a triangular prism. So this side here in the back, this space no longer exists. That is a 5 though, so we want to keep that in mind. That space no longer exists. The sides that exist, well, we have a back side, we have a top, and a bottom side, and we have, I'm highlighting a whole bunch of this, but we have kind of, I don't know how to describe it there, maybe like a left side and a right side. So that is what we cut it into. Let's make a net of it so that we can understand what this prism is a little better. So I'm going to do the back side first. We're going to start with this back part. The back part is going to look like this. So again, this grid right here, each grid line represents 1 inch, so it's 1 inch tall by 1 inch wide. To start out, here's where we want to put that back side that I highlighted first in pinkish purple. First thing we're going to do is I'm going to have you imagine that we took this and we actually rotated it a little bit, so we spun the shape. The reason I'm doing that is these triangle sides, we want them to look nice on our grid lines. So bear with me, let's do this. So we're going to put this back side. This back side is going to start at the top here, and we're going to go 4 inches in. So 1, 2, 3, 4, right there. And again, we are starting with this back side, so I'll use that color. All right, so looking at it, well, I kind of scribbled it out up here, but we'll free it up. This is 5 inches. So if I rotated it, though, it no longer goes along the top. It's going to go along the side. So I'm going to go here. I'm going to count down 1, 2, 3, 4, 5. There we go. I notice it is 6 tall, so 6 inches tall. Remember, I rotated, though. I spun it. So this is 1, 2, 3, 4, 5, 6 over there, and my final side is going to be right there. I'm going to go ahead, I'm going to take my ruler, and I'm going to draw my line. There it is. I drew my lines in, even shaded in my box here, so it's easy to recognize, hey, this is the back side of this right triangular prism. Now let's go ahead and let's put the rest in. So the rest of this thing, we look and we see, okay, if this is the back side, I'm going to pretend that we have a fold occurring. Let's see, we'll put our other fold. We'll unfold this edge. So this edge right here, this side, is going to go underneath it. So when I am plotting this, I'm saying, okay, remember, I rotated this so that I have nice triangles on the side. This right here, so this distance is 3. When I rotate it, the 3 starts to go up and down. So I am going to count from this corner right here. Remember, this corner is actually this corner. I go down 1, 2, 3. So I went down 1, 2, 3, and this distance right here is still 6 inches. So I go over 1, 2, 3, 4, 5, 6 inches, and I'm going to go ahead, put my lines in and shade it. And there we have we have this side in blue right there. All right, so go in this direction. I got the back side. I got this more front side. Now let's do this side also. Now this side is going to be a different, it has slightly different dimensions. This side right here in orange, it's still going to be 6 inches tall, but now it's 4 inches wide. Remember, we rotated this too. So when we rotate this side, this distance actually becomes more horizontal. So my horizontal distance, I'm sorry, I meant to say vertical. So this is going to be my vertical distance from here, this face, this blue side, to here, has to be 4 inches. So I'll go down here. I'll put 1, 2, 3, 4. 6 over still, because it's still a height of 6, and since we rotated, that height is now horizontal. And there we have that. I'll go ahead, I'll make my sides. And there we have that. We now have this side on the right. Okay, so we got 3 sides total, the one in the back, the one on the left, the one on the right. But don't forget, we also have these triangular bases that I highlighted in yellow pretty early on in the video, so top and bottom. So let's see how that works. So to make this work, we're going to look at this part right here. And the reason I'm focusing on this part right here is if I look, I say, okay, well, it's a right triangular prism. So the triangles are right triangles. Let's go ahead and let's see. This is the longest side. Right here, these are the sides that have 90-degree angles. It doesn't look like it's so much from here because it's tilted, it's slanted, but those are our 90-degree angles. So this one here, let's imagine I fold this top part, I fold it out like this so that we're going along this line. So what is the distance that it folds out? Well, it folds out this distance right here, which is 4 inches. So I go down here. Remember, I'm folding from this blue side, and I'm going out 1, 2, 3, 4. So fold it out that way. The base matches up because the base is 3. So I can see right there, base of 3. Well, that works. So I'm going to go ahead. I'll put my lines. Now this line, I'm going to put my diagonal line right there. I'll put my other line right about there. So there we go. And on the other side, we have the same deal. So this side now, I'm going to focus on this corner. This corner is being unfolded this way. So let's see, it's still going to have a base of 3. My slant is going to go this way, and it's going to have a length of 4. 4 away from our fold, which is being unfolded there. So let's see, 1, 2, 3, 4. There we have that. Draw our lines real quick. There we go. Okay. So now we have our net image created. Now we can go about finding the area, the surface area of this. So let's set up our rough draft. A rough draft will start with SA, and we're going to do it based on what we see, not based on this formula. We're going to see if this formula gives us the same thing. So based on what we see, I see three rectangles. So let's go ahead, here we go, I put them in. I used L and W for the length and the width, and then I also used my highlighter to show what rectangles I'm talking about. Plus, let's keep going. We have two triangles, but here's what I notice. I know the two triangles are both 1, 2, 3, 4. They both have bases of 4. 1, 2, 3, 4. And they both have heights of 3. So 1, 2, 3. So I'm going to do this. I'm going to put 2 multiplied by, then it's the base times the height. And again, that is going to represent the area of one of our triangles. This 2 times base times height represents the area of both of these triangles. All right, now let's keep going. Let's make this rough draft a little cleaner by putting in some values. I'm going to look at the length of the pink one. The length is 1, 2, 3, 4, 5. Multiplied by the width is 1, 2, 3, 4, 5, 6. Plus, let's see, length of this one is 1, 2, 3. Multiplied by, we know the width is 6. And finally, that orange rectangle, the length is 1, 2, 3, 4. And the width is still 6. Plus 2. Now the base of each of these, like we said, is 1, 2, 3, 4. So 4 for the base, 3 for the height. Oh my goodness, I almost forgot one thing though. We have to remember they're triangles. We have to multiply by 1/2. Longer question forget some things sometimes, so it's all good as long as we remember it at the end. All right. So from here, let's keep going. Now we can actually find the area by doing our multiplication first and then doing our addition. So after multiplication, we get 30 plus 18 plus 24 plus 12. Remember, the 12 came from actually doing all this, then multiplied by 2 again. After we do our addition, we get 84. So since it is area, we got to put units squared. In this case, it's going to be 84 inches squared. So we found the surface area of this is 84 inches squared. Now back to the question though. Marcus is thinking that surface area can be found using this formula. This formula here, 2LW plus 2LH plus 2WH, that was the formula that could be used for a rectangular prism. We just put a 1/2, so can we multiply the formula for a rectangular prism by 1/2 and find the triangular prism? Well, I want to remind you that our rectangular prism had a surface area of 108 inches. So 108, or I'm sorry, yeah, 108. I'm right. 108 times 1/2 equals 54. So 54, if we use that formula, we would have got 54. 54 is not the correct area, though. We found out using the correct way, where we found the area of each shape and add them all together, that we should get 84. So we would say, no, Marcus is incorrect. Just because a triangle is half of a rectangle does not mean that applies to prisms.